Can you remember longitudinal wave and transverse wave? Huh? We started that day. Do you have the copy with you? Huh? Saad and Jawad, do you have the copy with you?
Yes, sir. No, sir.
Yes, sir. Can you tell me again?
Yeah, you have the copy with you. What we started
Yes.
at the end of last class? What we did at the end of last class?
Yes. Yes.
We started. There are two types of
Speed.
waves: longitudinal and transverse wave, right?
Yes, sir.
So you wrote that heading. You write types.
Think so, sir.
Yeah, types of waves. You write today's date and write this types of waves. Then first one is longitudinal. Longitudinal. Longitudinal waves. And I'm giving you some examples of longitudinal waves. One is sound wave. Sound wave. Then a spring is compressed and expanded. Then seismic P waves. So these are the example of longitudinal waves. Okay, you should memorize them. Seismic wave means we are getting the waves from the vibration of earth. Okay, and P means primary wave. Seismic primary waves. Why they are called longitudinal waves, we will discuss. Okay. Then now another one, another types. I'm writing here. 2. In your copy, write one after another. But here I'm writing at the corner because here we have space. Then there is transverse waves. Transverse waves. First of
Sir,
all,
do we need to draw these diagrams again?
no, you do not draw now. I am writing the examples. You do it first. Whatever you did that day, you keep it there. Okay, now we are doing the examples. Water waves.
Sir, what is seismic? Sir, what is seismic P wave?
Okay, seismic wave means the wave we are getting because of vibration of earth. That is, earthquake, right? For understanding, you write earthquake.
And sir, what is the P in the middle, sir? P, seismic P.
P for primary waves. There are two types of seismic waves. One is seismic primary waves, another one is seismic secondary waves. So seismic primary waves are longitudinal and secondary waves are transverse waves. Water waves, then light waves. Light waves. In bracket write all the electromagnetic waves. Faiza. Hello, Faiza.
Hi, sir.
Yes, Faiza, how are you? Are you writing?
Yes, sir.
Faiza, are you taking notes of the electromagnetic waves? Then seismic S waves, a rope vibrates up and down. Huh? A spring vibrates shear wave. Etc. So, are you done with writing transverse waves? Are you done with writing the examples? Hello, Zawad, Mohammad Saad. Hello, Zawad and Mohammad Saad. Zawad and Mohammad Saad. Don't mute your mic, huh? Keep it open.
Hello.
Yes, keep your mic
Yes, sir.
open.
Okay,
Okay.
sir.
Unmute your mic, all of you, and take part in discussion. When I ask you, then and there you should respond. Look, we have here two waves, right? Are you done with writing?
Yes, sir. Yes, sir. Done.
What about Zawad and Faiza? Are you done with writing?
Sir.
Yes, sir. Yes, sir.
Okay, if you are done with writing, I can clear all the drawings, right? So look here, longitudinal and transverse wave. First you understand, then you draw and write the definition. What is called longitudinal wave? Why it is called longitudinal wave? Look, our energy is transferring right side. The spring is fixed here at the right, and one person is compressing and expanding the spring, and this way the energy is transferred till the end. So energy transfer direction is right side, And the vibration of spring, vibration of the particles in the spring, that is forward and backward. Look, arrows are given right and left. Okay, arrows are given right and left. So this vibration is happening forward and backward. That's why it is called longitudinal wave. And here you see the same spring, one person is doing the vibration upward and downwards. This is called shear wave. Shear means we are having the vibration of the particles upwards and downwards, and energy is transferred to the right again. Okay, if the vibration of particles are upwards and downwards with the energy transfer direction, that is called transverse wave. Is it clear what I said?
Yes, sir.
Kazi, Faiza, did you understand my explanation?
Yes, sir.
Did you understand? Faiza?
Yes, sir, I did.
Okay.
The one
If
that
you,
keeps vibration.
yeah, very good. If you understood, then now what you will do, you will draw like this. You will, what you will write, I am saying, you will only write longitudinal wave and draw this diagram. You do not need to draw the hand, just draw the arrows. Huh? You also show here, look, the spring. Here, when the person is compressing it, the spring is very closer, right? The part of the spring is very close. Then another part is expanded. Then again compression. Then again expansion. Then again compression. Then expansion. This way you draw. The way it's shown here.
Sir, what does compression mean?
Compression means the part of the spring is coming very close to each other. That is called compression. And expansion means you see the loop are going far away. That is called expansion. Okay. So you here first draw this spring, then show these two arrows. Okay. And here you label energy transport with another arrow. Then beside it, you draw another spring, which one is showing you upward and downwards arrow, and you draw the spring this way.
Sir, we cannot draw it beside, sir. We don't have that enough space in our copy.
So if you don't have space, then you draw it downward, just downwards, just below it. They who have space, then you can draw side by side, or you can draw one after another below. After your drawing is done, then tell me. Here you label. This one is compression and this one is expansion. You label. Who has space upwards, you label upwards or sideways, wherever it is possible, no problem. So here you write This is compression. Compression is equivalent to crest. Then expansion. In some places, you will get expansion as rarefaction. And it is equivalent to trough. Is it clear? Muhammad Saad, are you understanding?
Yes, sir.
Yes, do it. Do all the labeling. Shafkat. Shafkat Tahmid Adib.
Yes, sir.
How are you? Why you are late to join?
Sir,
Sleeping?
vacation.
Sleeping or taking breakfast?
No, sir. Feeling drowsy.
Drowsy. Okay, look, this one is crest. And this one is trough, right? Draw all this. Label energy transport, upwards and downwards vibration, give the arrows. Here forward, backward vibration, you give the arrows. So it is crest. And it is trough. Already we got the discussion about crest and trough, so now it's easy for you to understand. Crest, trough. Then now I'm writing the definition. Definition of longitudinal wave. Longitudinal wave. If the particles vibration is forward.
You wrote vibration.
Vibration means,
No, sir, you wrote vibration.
oh yes, thank you. Yes, thank you. If the particles vibration is forward and backward, sometimes we say forward and backward, sometimes we say right and left, right and left, or we say parallel. Okay, any way we can say it. If you are writing forward backward, it is correct. You say right and left, it is correct. You are saying parallel, it is also correct.
So, sir, transverse waves can vibrate up and down.
Yes, up and down. I'm writing. It is not done yet. You write completely with energy
Alright.
transfer direction. Look, energy transfer is going right side, isn't it? So your particles vibration is forward backward in respect to what? Energy transfer direction, right? With energy transfer direction. Then it is called longitudinal wave. Examples already we gave at the beginning. What are the examples, Kazi?
Sound wave, semi-P wave,
Yes. Seismic P
seismic
wave,
wave, seismic.
sound wave, then another one I gave, right? Did I give
A
another one?
spring is compressed.
Yeah,
Spring is compressed and expanded.
yes. So that one is also there with us here. Now, transverse wave. Transverse wave I'm writing here, you write in your suitable place, no problem. Transverse wave. Now you can make the definition of transverse wave. You can help me to make the definition. How can we write transverse wave? Yeah,
Sir, right or left or parallel? Sir, after parallel, sir, what is written?
yeah. After parallel, I wrote with energy transfer direction. Then it is called longitudinal wave. Now you can see Mohammed
Yes, sir.
Saad.
Yeah, yeah. So
transverse wave. Tell me the definition.
if the particles vibration is okay, upward and downwards,
Yes. In bracket, what will write?
upward bracket a
Perpendicular.
left to right.
No, not
Oh yeah,
left to right. That is perpendicular. Okay, only perpendicular will write.
Yeah, with energy transfer direction.
Then it is called transverse wave, right?
Yeah.
If the particle's vibration is upward and downward or perpendicular. With energy. Rabi. Hello, Rabi. Are you writing?
Yes, sir.
Please write the definitions
Yes,
I
sir.
wrote. Longitudinal wave. If the particle's vibration is forward and backward, that is, we can say also right and left or parallel with energy transfer direction, then it is called longitudinal wave. Now we are writing the transverse wave one. Then it is called transverse wave. Is it clear? Aisha.
Yes, sir.
Hello, Aisha. Aisha, do you understand?
Yes, sir.
Okay. So you have any questions on the longitudinal and transverse wave? Anyone?
No, sir.
Okay, look, I told you to draw this, okay? These all things I told
Yes, sir,
you
we're
to
drawing.
draw. And you should also label the way I label them.
Yes, sir. We are
See?
leveling.
You see, I showed you compression, expansion. For longitudinal wave, I showed you compression, expansion. Expansion
Yes,
is
sir.
also known as rarefaction. And rarefaction, expansion, this is equivalent to trough. In transverse wave, you are getting crest and trough. And in longitudinal wave, you are getting compression and expansion. So your compression is equivalent to crest and expansion is equivalent to trough. Is it clear?
Yes, sir. No, sir.
Okay. Yes, tell me.
Sir, it is not clear, sir. Can you, sir, repeat again, sir?
Okay,
So,
look. When we are representing longitudinal wave in our waveform, that time also we are using the same diagram. This way. Like you are getting
yes, sir.
one wave of sound. Okay, like this. So in sound we are getting what? Compression and rarefaction, right? Of the air molecules. So that time we are showing this one crest as compression and trough as rarefaction. Is it clear? Hello?
Sir, which one is right? The same thing, right? The
Yes, yes.
crest.
Crest for compression. You see, compression start with C, crest start with C. Just remember this way. Does it work?
Yes, sir.
Yeah, this is the technique to memorize easily. So done? If you are done with this part, then we can go to another one.
No, sir, not done, sir.
Yeah, do it fast.
Sir, I'm writing the definition, sir.
I am also labeling again crest. This one is crest. Crest for compression. Then trough for expansion. Done?
No, sir.
Yeah, Zawad. Kazi. Hello, Kazi.
जी सर बोलो सर
You understood everything?
थिंक सो सर
Rabi. Rabi. Hello, Rabi.
Yes, sir.
You understood everything?
Yeah. Yes, sir.
You took the notes?
For the most part.
Yeah. And before your joining,
Yes,
we
in
also
my
discussed
copy.
the examples. You should check out the
I will
recordings.
see the
Okay.
recording.
Yeah.
Okay, sir.
So, Saad, you are done. I think
Yes,
you are
sir.
done with all the writings, right?
Yes, sir, I are done.
Yeah. So you give me the examples of transverse wave.
Examples of transverse waves are
They
all
who
the
are listening, you
electromagnetic
can write.
waves.
They who are listening, you can write the examples. He is saying you can write quickly. Yeah.
Water waves, light waves, in bracket all the electromagnetic waves, seismic S waves, a rope vibrates up and down, a spring vibrates with shear wave.
Yeah. This is called shear wave. Look, a spring can be compressed, expanded, and a spring can be vibrate upwards, downwards, and the one upward, downwards, that is called shear wave. So shear wave one is transverse wave, and compression, expansion one is longitudinal wave. Clear? Now,
Yes, sir.
Kazi, hello Kazi.
Ji sir, ji sir, ji
Are you
sir.
done with all the writings?
Yes sir, I have wrote everything.
Yeah, can you send the participants' attendance in the group, physics group?
Yes sir, sending.
Yeah, quick. Then
Science physics.
we can go to next part. Done, all of you are done.
Sir, sending done.
Yeah, writing done, all of you. Taking notes done. If you are done, then we can go to next part. Can we go to next part?
Yes, sir.
Okay, now we are going to the notes where we discuss longitudinal and transverse wave. Okay, I want Shafkat to read. Shafkat, can you read please? Shafkat. Hello Shafkat.
Oh, yes, sir.
Please read from longitudinal wave.
Yes, sir. In a wave, if the vibration of particle is parallel, left and right, with the direction of energy transfer, then it is called a longitudinal wave. Examples of longitudinal wave include sound waves, ultrasound waves, seismic P waves. P waves mean pressure or push waves, which are created due to compression and rarefaction, expansion of particles of the medium, solid, liquid, or gas.
Okay, the one compression rarefaction, that is also called push waves, right? And this is also called primary waves. Okay, P waves, and it is coming from the earthquake. You know, during the earthquake there is vibration of the earth, right? That vibration, if it is forward, backward, that is called P waves or primary waves or push waves. Look, we gave the diagram to understand more what is rarefaction, what is compression. This note is uploaded in your Google Classroom. Please check it there. Here is one tuning fork, which one is producing sound in the air. Okay, tuning fork. And we are seeing that the tuning fork is vibrating. And because of this vibration, there is compression and rarefaction in air, and this way sound wave is traveling right side. Okay, so transfer of sound wave through air by compression and rarefaction, this is longitudinal wave. Now Ravi, hello Ravi,
Yes, sir.
read transverse wave.
Okay, sir. In a wave, if the vibration of particles is perpendicular up and down with the direction of energy transfer, then it is called a transverse wave. Example of transverse waves include ripples on the surface of water, vibrations in a guitar string, and electromagnetic waves Example: light waves, microwaves, radio waves, seismic waves. Seismic waves may be a thought of as shake or shear wave.
Okay, it is also called secondary waves. Okay, in earthquake we are getting it. When the vibration is perpendicular, that time we are having shear wave, transverse wave. So transfer of water wave by perpendicular or up and down vibration of particles, it is called transverse wave. It is one of the examples of transverse wave. And after that, in our next class, we are going to discuss reflection and refraction of waves. Okay, reflection means returning back. Returning back. You see, there is one surface, from there water wave is coming and returning back. This is called reflection. And refraction means, in refraction, it is changing the direction. You see, water wave is going in this direction, then it is changing the direction in the same medium or in the same path, then it is called refraction. Okay, in reflection, we have angle of incidence and angle of reflection are equal. But in refraction, angle of incidence and angle of refraction are different. We will have detailed discussion in next class. Inshallah, be present in class. If you are present, then you'll understand more. Thank you so much. Thank you so much for joining. Allah Hafiz.